what each symbol means. So first get up for me. Area for trapezium revision. Area of trapezium revision. Okay? So let me quickly give you a sketch of this trapezium I've given you. Okay? One side going to this end, then this end. Here we go. Let's move up George a little bit. Here we go. Alright, yep, there we go. Good. And then now I had told you that this had a length of 13 centimeters, had a height of how much? 4.5 centimeters. And then I told you that this section up here had a length of 5 centimeters. Alright, everybody? Okay, so let's start off with the formula. Let's start off with the formula.
I did it using two methods.
Can you put that for me?
I used two methods.
Okay, so you use the counting method and you use the formula method?
I use the formula method. I don't know if I would call it counting method.
Okay, tell me what did you do? So the formula firstly, did you have this for the formula? We said that the formula was what? Wasn't it similar to the formula for a triangle? But in the case that we had not half times b times h, but we have to add this section. So we call this b. Seen that? We call this h. But Alex, look at this for me now. We call this section a. And remember the a for triangle said half times base times height. But we couldn't possibly use that formula. Why? Alex, we have an a right here. George, do you see that? So what do we say you must do? We're going to have the formula half times base times height. But what do we say we're going to do? We're going to add the a into the formula. Clear? Everybody remember that? So we're going to say not base times height, but base plus a times height. Everybody clear? Yes sir, no sir, maybe so sir, I don't know sir. Something guys, come on.
What is 8?
Let me go over it again. We always know that in a triangle, Michael, this part would have been called the B, this is the base, right? We know that the height is the vertical, and we always call it the h. But do you realize we have a length here as well? From here to here? See that? In a normal triangle, wouldn't we have just have this? We wouldn't have had any a in a normal triangle. You see that? So that's why we must add the a into the formula. Clear everybody? Alright? That's why we add the a into the formula. Okay. No, I want somebody's help now. Let me call on Aliana.
Yes, sir.
Tell me what to write now. What is the b? So I'm going to say half times b. What's b?
Sir, can you put it a little closer to the board, please?
You should have done this for your homework.
Hold on, sir, let me get to my book.
Alright, there you go. Can you see the board now?
Sir, the base is 13 centimeters.
13 centimeters, excellent. Good. We're going to add the A component to the base. So what was the A again?
4.5 centimeters.
No. Let's look at it closely. The H was the 4.5, but what's the A?
5 centimeters.
5 centimeters. I'm literally moving mountains for you guys. 1 second. Alright, there we go. So we're gonna say 13 plus 5. Alright, are we finished? Let me ask Naima, can you hear me?
Yes, sir.
Right, I see a message. I'll read the message in a second. What do we have to add now? Or multiply rather? What are we forgetting? The H, correct?
Yes, sir.
So we're going to say multiply by the H, which is, how much is the H again?
4.5 centimeters.
4.5. But I want to make sure that you guys make no mistakes. So before we calculate this, we're going to go over BODMAS. Here we go. We're going to go over BODMAS. So I'm going to call Alex. Alex, okay? Repeat that for me, Isabella.
I got CM.
Yes, I'm going to add it back when I'm finished calculating. I'll add it at the end. Don't worry. Let's look at the BODMAS. Alex, are you here?
Yes, sir.
Right. BODMAS. Do you recall what this means? BODMAS. What does the B stand for? The B stands for butterfly. The B.
Butterfly stands for brackets. I'm not understanding this.
B stands for brackets. Pay attention to the body.
That's what I said.
Yes, brackets. Alex, look for me. This is a very complex statement, right? We have fractions, we have numbers, we have multiplying, and we have the sunlight being very disruptive. But before we can answer that question, we must know, what do we solve first? Do I solve the fraction first? Do I solve the bracket first? Or do I multiply everything by 4.5 first? So I'm going to show you the sequence. And I'm saying the first thing you should always work out is the brackets. Then the next thing is division. So brackets over division, multiplication,
Addition and subtraction.
right, multiplication, addition, and subtraction. So this is the rule for whenever you're going to calculate anything. If you have a bracket first, Alex, everybody, we're going to solve what's inside the bracket first. So let's do that, Alex. What's 13 plus 5, since that's what we're going to solve first? What's 13 plus 5? So I'm just going to write back everything else times the 4.5. But I must solve the bracket first. So what's 13 plus 5, Alex? 18, good. Good. Take that off from everybody, and then we're going to move to the next step. Alright, after I have the 18, can I divide anything? Do you see any division happening here, everybody? No, right? No division. Or is there? Don't you have a 1 divided by 2? So if you want, you can just turn 1 divided by 2 and divide it itself. What is 1 divided by 2? Isabella.
Like.
Alright, Isabella, what you say? A half. So 1 divided by 2 is the same thing as 0.5. Right? You could put either and your answer would be correct. Let's quickly move on. So what is half of 18? Everybody, what's half of 18?
9.
9. So what I have left is 9 times 4.5. And what's 9 times 4.5?
40.1 centimeters square.
14.5 centimeters. Don't forget.
Also 40.
14, okay. 14 centimeters squared. See that, everybody? 14.
Also 40.5.
Oh, your voice is very deep, my bad. 40.5. 40.5, my bad. 40.5 centimeters squared. Alright? Any questions? That was a revision of calculating the area in a trapezium. So what that means, because I know you guys are going to say, so what that mean? This region inside right, is 40 centimeters squared. Okay, now let's move on to the next topic. We're going to talk about circles for a brief moment. Let's go back to that dreaded circles. Okay.
Circles are objects that don't have any corners.
Right, okay. And we learned the area of a circle. Thank you, Chuck. We learned the area of a circle last term. We learned the area by the formula. But what if I don't want to know the area of an entire circle? Here's what we're going to talk about. Alright, who can recall parts of a circle? Alright, parts of a circle, let's go. Any part of a circle, quickly. Diameter, let's write that.
Radius, circumference, diameter.
Radius. Any other part? Chord, I like that one, chord. Right. Any other comments again?
An arc.
Arc, that's a good one. Arc. Tangent. Alright? Circumference.
What is it? That one.
Sir,
Yes?
can I take a picture in the shot?
Sure. Alright? So the parts of a circle, let me just finish them quickly. We have arc. We also have sector. I'm going to put a picture in the group. But before we move on, I need you to understand the difference of the different parts before we move on. So, let's quickly draw a circle and we're going to just fill in some details about it. Alright? Let's see if I can draw a perfect circle again. Here we go. 1, 2, 3. Wow! Is somebody amazing or what?
What happened?
I drew a perfect circle. Come on, pay attention.
Sir, that does not look very perfect.
That's the size of the earth. That's basically perfect. Let's go. Alright. First thing, let's identify the diameter. Isabella, you gave me the diameter, so where is the diameter?
Diameter is 2 radius.
So this is the diameter?
2 radius.
2 radius attached together. There we go. So below it, I want everybody to draw this again. It's very important that you draw it. Stick with me. So I'm going to write diameter right here. Good. The next part that we're going to highlight is the radius. Benjamin, you gave me the radius. What's the radius?
Yes, is the half of a diameter.
The radius is from the center point to the edge of the circle.
Right? Center point to the edge of the circle. We're going to put radius right here. R-A-D-I-U.
And also, I don't know, this is kind of stupid, but two radiuses equal a diameter.
Yeah, you're right. 1 radius, 2 radius. Excellent. Good.
3 radius.
The next thing, I heard Aliana. You said chord. But what's a chord? Tell me now. On a diagram, where's chord?
So where the radius and the diameter is, it's below it, but it's attached to the circle.
So it's a line, right?
Small line, but it doesn't fill up a lot of the circle space.
So would this be a chord?
Yes, sir.
Right. So a chord is a line in the circle that does not pass through the center point. Right? So we're going to put chord here. But as you can see, I use the wrong color. So let me just quickly switch that around. Let me use green. Here we go. I'm going to put chord. Good. The next thing, somebody said ark. Noah's ark. Where is Noah's ark on this? Who said ark?
I don't know.
See what it is?
Benjamin, where's the ark here? Hello?
Let's see what
Yes,
it
sir.
is.
Yes. What would be an arc?
An arc would be a line on the circumference, or a part of the circumference.
Part of the circumference. So let's highlight it. Let me use another color. Let's use pink. Right? Let's use this region right here.
That is an arc.
That would be an arc. Okay? And finally, a sector. Who can tell me, which bright person can tell me what a sector is? Because that's what we're going to actually go through. So I'm surprised somebody said sector. Where's a sector on a circle?
Isn't a sector like a pizza slice, kind of, in a way?
Alright?
Like,
Alright, let's write that. Like a pizza slice, kinda in a way. Good.
kind of in a way.
Right. But a sector is going to be a portion of the circle, right? Subtended by an arc. Let me give you an example of a sector. Let's say that I am looking at a quarter of the circle. How would that look like? Wouldn't that be a quarter of a circle? Hello?
Yes, sir.
Right. So therefore, a sector is a combination of some things. It's a combination of a radius.
Someone is eating in class.
Who is eating? Who is eating?
Check your recordings if you like to.
Alright, I'll check my recording.
Recordings of them, brother. You're too cruel.
I'll check my recording. That person will never eat again.
Yeah, but this is eating in class.
Your recordings? That's
Yeah.
illegal, bro. Without his permission.
I'm always recording.
Okay, sir, but I ain't eating in class.
Don't worry. For the person that was eating, you must share with us. But let's focus. Quickly. So no eating in class though, because we need to focus on this. The sector is a combination of some things. Let me highlight it for you. We have an R here. We have a center point here. We have another R over here. And we have an arc here. Alright? So write that for me. A sector is...
Oh, Ethan turned on his camera and just walked off.
A sector is a combination of two radiuses and an arc. A sector, right for me, is a combination of two radius and an arc. And now that leads us into today's topic, which is how to find the area of a sector. How do I find the distance inside of this arc? Right? So I can know if two of every animal can fit in that inside this arc. Alright? That's what we're going to find out today. Can Noah's Ark really fit all these animals?
Okay, what's a Noah's Ark?
I'm just kidding. You don't know Noah's Ark?
Huh? No.
The thingy in Noah's Ark is animals and humans.
Why?
Because it was a massive flood, if I was correct. I don't even remember the story myself.
Here we go. Focus. Length of an arc. Length of a sector, rather. Length of an arc and area of a sector. But the first one we're going to look at is area of a sector. Alright, stick with me now. Stick with me. It's very simple and it's very basic. What was the formula for the area of a circle? Anybody?
Pi r squared.
Pi r squared, let's write that. Everybody agree? Okay, what portion of the circle am I trying to find?
Right angle.
No, what portion, as in fraction, what fraction of the circle is, am I trying to find the area of? Repeat that for me.
Quarter.
The latter?
A quarter.
A quarter. There you go. Right? So, I am trying to find a quarter of the circle, so therefore the area of a sector is going to be a quarter times pi r squared. Simple. That is when you have a quarter shaded. But what
Who
is...
mentioned the sector? Who mentioned it?
It's very simple though. Stick with me. So this is the formula for this area. Just a quarter of the area of a circle. Just a quarter of it. Since that's only the quarter that we're shading. But this formula can change depending on this area of the sector itself. So I'm going to show you another circle that has more than a quarter shaded, and you're going to tell me the formula. Alright? Here we go. What if I wanted to find the area of this sector? Look at this one, everybody. Oops. Here we go. Pay attention. Camera's on. Or my camera magically stops working. Alright, there we go. Good. This is half of a circle, correct? Everybody see that?
Yes.
So, therefore, I'm going to say the formula to find this area is going to be half of pi r squared. It's that simple. So the formula to find this area, since it's half of a circle, is going to be half of pi r squared. We're going to do one more example, and I want Alex to tell me the answer. Very simple, Alex, don't worry.
Hey, why do I have to do it?
Because you're the coolest out of everybody. Let's go.
I'm what?
Because you're the coolest person out of everybody. That's why. Let's go.
I'll take it.
Yeah, take it. Let's go. Here's the next one. Let's say that is my sector, Alex. How many of the circle do I have here?
Ready, answer?
What fraction of the circle do I have represented here?
Pac-Man.
It's more than half, correct?
Yes.
Is it the entire circle?
No.
Right, so it's a portion of the circle. So what is more than half but less than 1? So it has to be not a half, but 3/4. Right. Thank you, Alex. There you go.
You're welcome, sir.
Right. 3/4. Okay? So the formula to find the area of this now would be 3/4 times pi r squared. You got it for me? 3/4 times pi r squared. Alright. So the formula, therefore, we're going to write the general formula. Everybody has taken off the diagrams?
Sir.
Yes, sir.
Alright? Because I'm going to erase the board in 5, 4, 1.
Sir, can you see the next sign?
Alright, let me take a picture of the board. 1 second. There you go. And here's the next side. There you go. And there's the next side. Hold on. There you go. So let me take a picture of the board for you. Alright, can you guys see the picture in the group? Hello, can you guys see the pictures in the group? Let me take it again.
Oh, sir.
I don't see it yet.
Alright, it should be loading up.
I don't see it, sir. I don't see it.
Good.
Okay, sir. Now I get it. Yeah, I see it as well, sir.
Good, good, good. No.
Sir, on the other side. Forgot to take out.
Right, there you go. Alright, so this is very easy. Alright. The next thing we're going to learn about is the length of an arc. But before we go there, we must write the formula for the area of a circle. So write this for me. The formula for the area of a circle, let me erase this. The formula for the area of a circle, for the area of a sector. The formula for the area of a sector, let me write it over here. The formula for the area, I heard a ding. Let me see which student is that coming in so late. That's Jamie. Okay, good afternoon, Jamie. Camera's on for me, everybody. My camera magically stops working if yours isn't on. Yifeng, Benny.
There's some good lies.
Yeah, I don't know why. It just clicks off every time someone's camera's not on. So I'm waiting on Benjamin, Yifeng, and Jamie. 5, 4, 3, 2, 1. Quickly. Yifeng, are you there? I'm put you in the waiting room. Message me when you're back. Okay, good. There we go. Benjamin waiting on you. Jamie waiting on you. But let me continue writing. By the way, my handwriting has gotten a lot better, right? I've been practicing. The formula for the area of a sector is very simple. The sector as a fraction of its circle multiplied by the area of a circle. Wow, that is actually really neat handwriting. Thank you. Okay, I'm going to give you a second to turn it off, and then we're going to move to the arc. No, Noah's ark. Can I rub this off?
Not yet, sir.
Oh, sir, I'm still writing.
Alright, I thought you were admiring my handwriting. Alright, let's continue in a few.
Finished, sir.
Finished? Let me take a photo for those who aren't. So the formula for the area of a sector, highlight area of a sector for me, is the sector as a fraction of its circle times the area of a circle. Alright, let me take a picture. There we go. Good. Let's continue now. Here we go. Alright, so we're going to move on now into the length of an arc. Alright. This is going to be your favorite topic, and let me explain why. We'll go over here. There we go. It's going to be a favorite topic. Let's prove it. 1 second. Good. Look at this one now. Let me just quickly draw a small arc for you from a circle. Let's say that I have alright? This is an angled line, right? This is technically a line, but this is an angle. Everybody agree? It's an arc. But what's interesting about it is that what was the circumference of a circle again? Anybody recalls?
I times diameter.
Right, so C was equal to 2 pi r, or as Isabella just said, pi times d.
Yes.
Are you sure?
Maybe. I'm not sure.
Alright, let's test it. Let's test it. I like to test. So, let's say I have a circle of 36 diameter. We're going to calculate the circumference using those two formulas. So let's say we use 2 pi r and let's say we use pi d. We should get the same answer. Let's check it. Alright, let's do my method first. What is half of 36?
Half of 36. Let me calculate that.
We're going to check if we can use those two formulas together. Isn't it 18?
Yes, sir. It is 18.
And pi is 3.14. So I'm going to say 2 times 3.14 times the 18 you just told me. What does that give you? What is 2 times 3.14 times 18?
Sir, so that would be... I never really calculated it, sir.
Alright, let me give you a help.
So 84.28, I think.
84.28.
Yes, sir.
Alright, now let's try Isabella's way. Let's test it. We're going to just say 3.14.
13.
Alright?
113.04.
For this answer, 113.304.
So my calculation.
0.04.
Alright, 113.04. 113.04. Alright, look at this one now. We're going to say 3.14 times D, which is 36. Tell me what you get here.
I'm sorry, take.
What's 3.14 times 36? Anybody? Hello?
Yes, sir.
What's 3.14 times 36? We're testing the two formulas now. We should get the same answer. Do you agree?
Yes, the same.
Same answer.
130.04.
Alright.
Yes.
That means, yes, Isabella, you can use either of these formulas to find the circumference of a circle. Clear? Alright? So, with that said, let's continue what we're saying now. So, the circumference, as we know, would have been the entire distance going around, right? Right, everybody?
Sir?
I'm not hearing everybody. I want to make sure you guys are paying attention. What did the circumference say? Circumference is a distance around a circle, right?
Yes, sir.
Right. So pay attention for me now. If I have a portion of a circle highlighted, like let's say from here to here, you start to realize something. It's the same thing like an arc, the same thing like a sector. So what happens is that to find the length of an arc, we are just going to say how much of the circle does it take up multiplied by the circumference of a circle. So it's the same thing like a sector. So let's do this. This arc right here, everybody, isn't it a quarter of the circle?
Yes.
Alright? So stick with me now. Really and truly, when we look at half of a circle now, this would have been one section and this would have been another section. So whenever we say that it takes up half of a portion, let me highlight it in another color. Alright? Look at this one now. This section is one part of an arc. So whenever I say it takes up half of it, like for example here, the formula, oops, I think I'm gonna have to go through arcs at another class since the timer up. Alright, since the timer finished, I'm probably gonna just have to go through. Alright, stick with me. I know that the timer is up, but I'm just going to introduce this and the next class will continue. Okay. So stick with me now. If I'm looking at just this section, this upper section, pretend like this doesn't exist. Pretend like this section doesn't exist, right? Can everybody see my screen?
Yes, sir.
It's saying... Alright.
Circular that was split in.
So if it's a half of a circle, then that means I can say the radius of this arc or the length of this arc isn't that half times pi r Somebody else?
Sir, I think that would be correct, sir.
Right. Let's look at it. When we said 2 pi r,
that means that it's a circle, one whole circle.
right. When we said it was 2 pi r, that was 2 parts of a circle.
Parts of a circle, yeah.
But if I just say pi r, that is half of a circle. Clear, everybody?
Yes, sir.
Alright, let me give another example for those who probably don't see it yet. So take this out for me. So let me give another example before you go. And then next class we're going to pick up on it. Let's say...
Sir, I get it, sir, but I really didn't know that, sir.
Alright, no worries. So here's another example. So take this out for me. Let me take a picture of it for you before I erase it. Okay, here we go. Let's say I am looking at the entire top half there, right? Not just half of it. I am looking at everything up here. What would be that formula? I'm looking at everything.
There was a background, sir, noise.
Right. Listen for me. I'm saying that I am no longer looking at this half of this semicircle. I'm looking at the entire section. What would be the distance of this part of the arc itself? Isabella?
Half?
Remember, 2 pi r represented 2 parts of a circle completed together, right? So if I'm looking at the total distance of just one part, isn't that just going to be half of 2 pi r?
Pi r square, sir, if I'm correct.
Which would just be pi r.
Pi r, yeah, pi r.
Understand, everybody? So the length of this arc, length of arc is equal to pi r. Why? In the formula, we calculate per semicircle. That's why we say 2 semicircles to make 1 circle. Okay? So if I want to find the entire length of 1 semicircle, I just say pi r. Alright? I'm going to leave you with one more and then we'll finish for the day. One more.
Question.
Yes?
Can the formula be half times pi d?
You're asking the formula can be half times pi d?
Yes, sir.
Alright. Yes, it will. Alright? Alright. Let me give another example just to explain it for you. Here we go. What if I had not a full, what if I had there we go. 1.5 of a semicircle. So I have 1 plus
That would be
half. What would be the formula?
I don't know, sir.
Follow with me.
Over 4 times pi d?
Stick with me. We're gonna still use pi r for now. We're gonna just use pi r for now. Pi r. You're going to add these together. What is 1 plus a half? 1 over 1 plus 1 over 2. What are they equal to?
That would be
3 over 4?
Stick with me. What's the lowest common multiple of 2 and 1?
1 itself,
1 into 2 goes how many times? 2 times. 2 times 1 gives you 2 plus 2 into 1. How much times does it go in the by itself?
1
times 1 gives you 1. So therefore your answer is 3 because 2 plus 1 gives you 3. over 2. See that?
You can see, sir. That's 2 times
1 plus a half.
3 over 2 pi r.
Right. 3 over 2 pi r. Isabella, because 1 plus a half gives you 3 over 2.
But that is not 1. That's only half of the circle.
Repeat?
But that's not 1. That's just half of the circle.
Remember, I told you, because we're finding the length of an arc, it doesn't work like the area. The length of an arc works in semicircles. That's why you say 2 pi r to represent one whole circle. See that? This is pi r, and then the 2 semicircles together to make a circle represents 2 pi r. Clear?
Yes, sir.
Alright? So, here's your homework for today. You're gonna take pictures of your notes from it and upload it on the portal, and you're gonna answer this one question for homework. Alright? This one question for homework. Here you go. Alright, look here for me. You see what time is it? So I don't overgo. Okay, good. Alright, I'm going to do over time. So here's the one question for me. Alright? Given that R is equal to 15, alright? And you have this circle. Find the area of the sector. Hello, good afternoon.
Afternoon, Mr. Thompson.
Hi, could I call you back? I'm in the class.
Okay, alright.
Sorry about that, guys. You're gonna find the area of the sector given that the radius on the diagram shows you the section of the sector. So this is the section that you're looking for. Right? And you're going to find the sector. Find the area of the sector. And find the length of this arc. Find the length of arc.
And what does that over there say? R equal IS?
Where?
What does that say? R equal 15?
Yeah, R equal 15. So you're going to find the area of this sector shaded in blue, and you're going to find the area of this arc shaded in pink. Shaded in pink. Clear, everybody? So don't put that. Shaded in blue and shaded in pink. My chalk are completely finished. Shaded in blue. In blue. And then the next one, shaded in pink. In pink. Any questions? Given that R is equal to 15 cm, my bad, 15 cm. So that's it for today, everybody. Let's start with